Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. CS 3301 Data Structures, Unit 4 Multi-Way Search Trees and Graphs. Now I'm going to explain Dijkstra's algorithm. Definition: the Dijkstra's algorithm finds the shortest path from a particular node called the source node to every other node in a connected graph. It produces a shortest path tree with the source node as the root. It is profoundly used in computer networks to generate optimal routes with aim of minimizing routing cost. Dijkstra's algorithm: input a graph representing the network under source node S. Output a shortest path tree SPTF with S as the root node. First, the following elements has to be initialized. An array of distances, dist of size V represents number of nodes, where dist of S is equal to 0 and dist of U is equal to infinite, where U represents a node in the graph except S. An array Q containing all nodes in the graph. When the algorithm runs into completion, Q will become empty. An empty set S to which the visited nodes will be added. When the algorithm runs into completion, S will contain all the nodes in the graph. Repeat the algorithm while Q is not empty. Remove from Q the node U having the smallest distance and which is not in S. In the first run, dist of S is removed. Add U to S, marking U as visited. For each node V which is adjacent to U, update dist of V as follows. If dist of U plus weight of H, that is U minus V, less than dist of V, then update dist of V is equal to dist of U plus weight of H, that is U minus V. The array dist of contains the shortest path from S to every other node. The working of the algorithm can be best understood using an example. Consider the following graph having nodes marked from A to G connected by weighted edges as follows. The initializations will be as follows. Dist of 7 is equal to 0 for S, and for all the other nodes infinity. And then Q consists of all vertices in the graph A to G, and then S is equal to empty. In pass 1, we choose node A from Q since it has the lowest dist of value of 0 and put it in S. The neighboring nodes of A are B and C. We update dist of values corresponding to B and C according to the algorithm. So the values of the data structures become dist of 7 is equal to 0, 5, 6 and all other elements are infinite. Q is equal to B, C, D, E, F, G and S is equal to A. The distances and shortest path after this pass are shown in the following graph. The green node denotes the node already added to S. In pass 2, we choose node B from Q since it has the lowest dist of value of 5 and put it in S. The neighboring nodes of B are C, D and E. We update dist of values corresponding to C, D and E according to the algorithm. So the values of the data structures become dist of 7 is equal to 0, 5, 6, 12, 13. All others are infinite. Q is equal to C, D, E, F, G. S is equal to A, B. The distances and shortest path after this pass are shown in the figure. In pass 3, we choose node C from Q since it has the lowest distance of value 6 and put it in S. The neighboring nodes of C are D and F. We update dist of values corresponding to D and F. So the values of the data structures become dist of 7 is equal to 0, 5, 6, 8, 13, 10, infinite. Q is equal to D, E, F, G. S is equal to A, B, C. The distances and shortest paths after this pass are shown in the figure. In pass 4, we choose node D from Q since it has the lowest distaff value 8 and put it in S. The neighboring nodes of D are E, F and G. We update distaff values corresponding to E, F and G. So the values of the data structures become distaff 7 is equal to 0, 5, 6, 8, 10, 10, 18. Q is equal to E, F, G. S is equal to A, B, C, D. The distances and shortest paths after this pass are shown in the figure. In pass 5, we can choose either node E or node F from Q since both of them have the lowest distaff value of 10. We select any one of them, say E, and put it in S. The neighboring nodes of D is G. We update distaff values are corresponding to G. So the values of the data structures become distaff 7 is equal to 0, 5, 6, 8, 10, 10, 13. Q is equal to F, G. S is equal to A, B, C, D, E. The distances and shortest paths after this pass are shown in the figure. In pass 6, we choose node F from Q since it has the lowest distaff value of 10 and put it in S. The neighboring nodes of F is G. The distaff value corresponding to G is less than that through F. So it remains the same. The values of the data structures become distaff 7 is equal to 0, 5, 6, 8, 10, 10, 13. Q is equal to G. S is equal to A, B, C, D, E, F. The distances and shortest paths after this pass are shown in the figure. In pass 7, there is just one node in Q. We remove it from Q, put it in S. The distance array needs no change. Now Q becomes empty. S contains all the nodes and so we come to the end of the algorithm. We eliminate all the edges or roots that are not in the path of any root. So the shortest path tree from source node A to all other nodes are as follows. Thank you.